Trigonometric functions. First we will see the angles. In simpler words, let's take a wall clock. If a needle is pointing at the 3 o'clock, then it is always considered that as the initial side, and any angle that is formed by moving towards anti-clockwise direction is called as positive angle. Similarly, any angle that is formed from that 3 o'clock position to clockwise direction is called as negative angle, and the line that is forming that angle is called the terminal side. If a rotation from the initial side to the terminal side is 1 by 3/60th of a revolution, then the angle is said to have 1 degree, and 60 minutes form 1 degree, which is denoted as 1 dash, and 60 seconds form 1 minute, which is denoted as 1 double dash. Similarly, for radian measure, in a unit circle, if an arc length of 1 unit subtends an angle, that angle is called as 1 radian. Just as mentioned above, anything that is in the clockwise direction is called as negative radian. Anything in the counterclockwise direction will result in positive radian. Radian and real number relation, they are one and the same, and degree and radian relation, which is 2 pi radians is equal to 360 degrees. So 1 radian is roughly is equal to 57 degrees and 16 minutes. Similarly, 1 degree is equal to 0.0176 radian. The notional convention is theta for a degree measure and beta for radian measure, whereas in real life theta is mentioned with a degree. The word radian is mostly omitted while expressing radians. Let's see some common trigonometric function. The cos 0 is equal to 1, cos 90 is equal to 0, cos 180 degree is equal to minus 1, and cos 3 pi by 2, which is cos 270, is equal to 0, and cos 2 pi is nothing but a repetition of cos 0 because it completed one full circle. Similarly, sine values, and sine 2 pi is nothing but a starting point again because it completed one full revolution. That's what they have mentioned here. If sin x value is 0, then x is equal to number n times pi, because sin results in 0 only at the at pi locations only. Either pi, 2 pi is nothing but 0 only, and n is any integer. Similarly, for if cos x is 0, then x is equal to 2n plus 1 times pi by 2, and n is any integer. With this we can derive other trigonometric functions also, like where tan x is equal to sin x by cos x, and cosecant x is equal to inverse of sin x, and secant x is inverse of cos x, and cot x is inverse of tan x or cos x by sin x, as long as the denominators are not 0. Whatever the denominators value mentioned here, as long as they don't result in 0, with sin and cos only we can arrive at all the remaining other values, remaining other functions. These are the most commonly used values. If you remember them by heart, it's going to save a lot of time in examinations. Then comes the sign of trigonometric function. Cos of minus x is equal to cos x, and sin of minus x is equal to minus sin x. How? Consider a unit circle. The coordinates and length are OPC is a triangle, and the coordinates are a comma b, and OCQ is again a right angle triangle where a comma minus b, because it's on the minus side of the y, and OP and OQ are hypotenuse, which is equal to 1 as it is a unit circle. Cos of x equal to adjacent side by hypotenuse, which is a by 1 equal to a, whereas cos of minus x is again equal to adjacent side by hypotenuse, which is again a by 1 equal to a. So cos of minus x is equal to cos x. For sin x, opposite side by hypotenuse, which results in b, whereas sine of minus x, opposite side is CQ, which is minus b by, since it's a hypotenuse is a unit circle is 1 equal to minus b, so minus of sine x. Signs of trigonometry function in different quadrant: first quadrant, second quadrant, third quadrant, and fourth quadrant. Here you don't even have to remember the entire table. If you just remember sine and cos, that itself is fine. With that you can arrive at tan, cosecant, secant, and cot. How? See, what is tan x? Sine by cos. So plus divided by plus is equal to plus, whereas plus divided by minus will result in minus. Minus by minus will give positive value, whereas minus by plus will give minus value. Similarly for cosecant, secant, and cot. Just make sure you remember sine and cos values by heart. Domain and range of trigonometric functions. If y equal to any trigonometric function, that trigonometric function is called as the domain of y. If y is equal to sin x, then domain of y is sin x. And the interval between the maximum and minimum values generated by sin x for all possible values of x is called the range. For example, y is equal to sin x, we know it's a sinusoidal curve, and the range is going to be from -1 to +1. The same is for cos, from -1 to +1. Whereas if y is equal to tan x, the range is going to be set of all real numbers, because it goes in both the directions of positive y and negative y, all the way up to infinity. For cosecant x, it's going to be like a greater than or equal to 1 or less than or equal to -1. The same for secant x, greater than or equal to 1 or less than or equal to -1. For cot x is going to be the set of all real numbers. Trigonometric sum, function of sum and difference of two angles. See, basically here we are about to see some 2021 identities, and you should know the identities by heart. There is no other way. Yeah, you can definitely understand how the identities are arrived, but at the end of the day you should know them by heart. It's going to save a lot of time in examinations. How? I will show an example here. See, while solving a problem, if you arrive at some pattern like this, tan x plus tan y divided by 1 minus tan x tan y, instead of using the same expression and taking them forward for multiplication, addition, subtraction, division, it's going to be difficult. It's going to be time consuming. If you know the identity of which is equal to tan of x plus y, then you can simply replace this by tan of x plus y. Now this is just one expression, and you can easily multiply them, subtract them, divide whatever in a much easier manner. It's going to be a smart work than a hard work. See, we already know the negative sign, negative of x inside a sine will result in minus sin x, whereas negative side of x inside a cos will result in positive cos x only. Similarly, cos of x plus y equal to cos x cos y minus sin x sin y. Let's take a unit circle and look at the triangles AOC and the other triangle BDO. X is the positive angle and minus y is the negative angle, and from x another the positive y angle goes. The difference between this small and both the lines, we will call it as an Z. Now AOC equal to, I have written it down, yeah. Actually we are trying to geometrically prove that the triangle AOC is congruent with BOD. How? What is the angle BOD, which is going to be y plus Z? Similarly, what is the angle of AOC? It's again going to be Z plus minus. Don't consider minus, we are just taking what is the angle. So it's going to be y plus Z. Again, both this triangle have like two lines which are nothing but the radius of the circle, which is unit circles. That means both the triangle have one angle equal and two lines are also equal, which means that the third line BD and AC is also going to be equal. So BD square equal to cos x. See, these values we are getting from the coordinates. You are already aware that if an angle x is there, then cos of that angle is going to be the x coordinate and sine of that angle is going to be the y coordinate. Here you don't worry about, sir, this is not a perfect right angle triangle, etc. Just focus on the angle. Even in real life, when we are applying trigonometry for in astronomy, large planetary bodies and like for large distances between stars, in nature there is no such thing as perfect right angle triangle. If we apply this principle, we are going to get, maybe okay, we are not getting a 100% correct result, but we will be getting a 99.9% or 99, at least 98.9% accurate result, which is far better than having no results at all. So here you don't worry about, sir, how come this is going to be, the x is not 90 degree, how come it's going to be cos x sin x. You just don't worry about it. They are still going to give a very 99% accurate result. So just remember that the angle of the cos of that angle is going to be the x coordinate and the sine of that angle is going to be the y coordinate. Similarly, you remember the coordinates, and we are simply deducing what is BD square using the coordinates. Similarly, we will deduce for AC square, and we know that since both the triangles are congruent, BD square is equal to AC square, which is equal to cos of x plus y equal to cos x cos y plus sin x sin y. Similarly, in the next identity, just replace y by minus y in the identity number 3, you are going to get this. Again, for the next identity, replace x with pi by 2 90 degrees and replace y with minus x. Then solve. Then in the sine of pi by 2 minus x equal to cos x, just solve the identity 5 with x is equal to pi by 2 minus x, and you will get identity 6. Similarly, sine of x plus y equal to sin x cos y plus cos x sin y. This can also be obtained using identity 5. And the sine of x minus y, see, it's basically one and the same, only the y sign has changed. Just replace minus y here and you are going to get this. Simply by playing around the values of x in identities 3, 4, 7 and 8, we can get all these things. Yeah, I know this is going to be, don't get overwhelmed by it. Just solve them once and remember these identities by heart. It's going to make you work smarter in exams than working harder in exams. If none of the angles x, y and x plus y is an odd multiple of pi by 2, then tan x plus y equal to tan x plus tan y divided by 1 minus tan x tan y. Why this condition an odd multiple of pi by 2? Basically they want to say that the denominator should not be 0, so that the expression becomes meaningful instead of having no answer at all. See, what is the tan x sin x by cos x? So divide both the numerator and denominator by cos x cos y, and we'll get tan x plus tan y equal to 1 minus tan x tan y. Similarly, in the above expression, replace plus y by minus y, you will get tan x minus y expression. The same, it is very similar to what we have solved above. Instead of taking tan x equal to sin by cos, you take cos by sin as cot x. Don't worry about this indeterminate if none of the angles. Basically they are trying to say that the denominator should not be 0, should not end up becoming 0. Similarly, you write and remember all the 21 identities. Just write it down on a paper from your textbook itself and keep it handy. Just look at them, be it a photographic memory or just knowing them by heart. Just remember them. Like I'm again repeating, it's going to save a lot of time in examinations and help you to work in a smarter way than harder way. I can definitely solve, but what I'm focusing here is like revising all the basic concepts. And yeah, if I'm solving them one by one, it's going to become very long video. But actually, even if you solve, you should remember them. That's what my basic point is. There are around 21 identities are there. It can come in handy not only in examination, even in real life. If any of you are end up becoming writing programs for radars or like programs for astrophysics and all, if you write an algorithm in such a way that whenever such an expression comes, if your algorithm is in a very shorter manner, much complex algorithm I'm talking about, the size of the program itself is around like in GBs, you can write the program in a much shorter way and make the computation in a faster way if you remember these identities. If you see all these identities, whatever is on the right hand side is a complex expression, and it will be very difficult to carry forward them for multiplication, division, subtraction, etc. in their complex form itself. On the left hand side, you can say that it is equal to the right hand side, but it is mentioned in a shorter expression. The shorter expressions are easier to take it forward for further mathematical operations. That's why these identities are there. Now comes the trigonometric equations. Equation involving trigonometric function of a variable are called trigonometric equation. The solution of trigonometric equation for which 0 less than or equal to x less than or equal to 2 pi are called principal solutions. The principal solution lie between 0 and 180 degree only, whereas general solution is from expression involving integer n, which gives all solution of a trigonometric equation. Theorem 1. For any real number x and y, if sin x equal to sin y, see, basically what it means is that y is nothing but the same point x. Maybe it had covered some 2-3 revolution. Let's say this is sine 0 and this is like a sine of 5 times 360. That means it had completed 5 revolutions, but it again reached at the starting point, right? So it's going to be the same value as sine 0, which implies that x is equal to n times pi plus minus 1 power n times y, and n belongs to z. Similarly, theorem 2, for any real number x and y, cos x equal to cos y, it is basically the same thing as mentioned here. The y is the same point in the circle. It had completed maybe few other revolutions to reach at the same point or at the equal point in another quadrant. X equal to 2n times pi plus or minus y, and n belongs to z. Theorem 3 is x and y are not odd multiples of pi by 2. Then tan x equal to tan y implies x is equal to n times pi plus y, and n belongs to z. That concludes the revision of the trigonometric equations and functions. The larger part of trigonometric is going to be chapter is going to be the identities, which you have to remember. Even if you understand that, that's a different thing. You have to remember them. Please try to remember them by heart. It may look intimidating, but trust me, it is very easy if you remember them and write it at least once.